2, we are asked to given the property of the several stochastic process. And the first one is the wide sense stationary process. Wide sense stationary process xt, and its property is that the mean of this stochastic process it must be a constant, and the autocorrelation of this process is only depend on tau, where tau is the difference of T2 minus T1. And the second one is the independent increment process. Increment process. So, as its name implies, it implies that xt1 minus xt2 and xt3 minus xt4 are non-overlapping interval. On the non-overlapping interval. x1, x2, and x3, x4 are independent. So this is the increment from xt1 to xt2, and from xt3 and xt4 is independent of each other. Pay attention that it must be the non-overlapping interval here. For the 3 Markov process, it is that the past state has no influence on the future state given the current state we have known. And to represent in probability form, we have the current states with the condition of past states, many past states, whatever many, it is independent. So it's just equals to the current states given the condition of the past one state. And the fourth one is the normal process. xt, given the random variable xt1, xt2, etc. They are jointly normal for any n and t1, t2 if it satisfies the following property. It satisfies this equation. Where x is equals to the column vector of each x, and it is this notation represents the expectation of xt, which is also the mean, and c represents the autocorrelation of x, the autocovariance of x. The fifth one is the Stationary is the strict sense stationary process, SSS. Strict sense stationary process. That is, the statistic is not affected by any time shift eta. So to represent in mass formula, it is the distribution function of this, the density function of this statistic process at T1, T2 is equals to this process at the time with any time shift, like T1 plus eta, T2 plus eta, etc., Tn plus eta. And the sixth one is the white noise. We denote Vt as the derivative of the Wt, where Wt is a Wiener process. And we say it is white noise if it meets the property of that the mean value of Vt is equal to 0 and the autocorrelation of T1 and T2 equals to this representation, where Qt can be any function. It can be a constant or can be like any function of t. The seventh is the mean ergodic process. If xt is a mean ergodic process, then it satisfies the limitation of 1 divided by 2t of the integral of this from minus t to 2t over x is equals to the expected value, which is the mean of this process. And this is for the mean ergodic process. And for the last one, it's a process satisfied to be March-Tenos is that the conditional mean is equals to the condition. To represent it is that it's equals to the condition, which is x1. So this is the property of those statistic process.